Hello students, let's begin the second session of petrochemical technology. In the previous lecture I told you about the origin of petroleum, petroleum exploration and brief introduction of petrochemicals. So now let's begin with the drilling and production of petroleum crude. How the petroleum is extracted and how the petroleum is produced. So you can see here this is a drilling rig, or it is like a drilling machine that makes a borehole inside the subsurface. So starting from the top, this outer structure is called the mast, and the top, that is called crown block. This crown block is nothing but a pulley that used to rotate and to uplift the drill pipes and lower the drill pipes or any equipment that is sent to the well. This is a traveling block, so this travels ups and down. Here a stand pipe is nothing but a drill pipe. Then you will see a rotary hose. This is a rubber pipe, and then we have mud gas separator. This is a separator for mud gas. The gas which is dissolved into the mud is separated into mud gas separator. Now at the top, this red color you can see, this is a blowout preventer. When your drill bit encounters the high pressure zone, that time to control the complete pressure, the blowout preventers are used. This is a power generation unit for rotary table to rotate the drill pipe. These are the mud pits. So using this drilling rig, we drill a well. This is a drill bit that cuts the formation, and this is the drill collar from where the drill bit is connected. So let's start with the next slide. You can see the detailed diagram of a oil well. You see at the top we have wellhead, and then this is a complete production tubing, final production tubing, through which the petroleum or crude oil is entering and going to the wellhead. And outer we have conductor casing. So this casing is used to isolate the formations so that the soil or formation should not fall into the borehole, or the hole should not be collapsed. After conductor casing, drilling up to some other depth, we use the surface casing. Then further drilling, then we use the intermediate casing, and again after drilling more deep, we are using the intermediate casing. Then finally the very small diameter hole, this pipe is called the tubing, and this red color you can see, this is a packer. Packer is basically isolating the annulus and borehole so that this fluid should not enter into this annulus. These are the key. This is for cement. So outside of every casing you can see a cement. Cement is providing a bond between the casing and formation, so that casing should not be move on. Casing should be stable, and this is borehole. This is a borehole, and this is packer. So that's how the oil well is planned and drilled like this. We have one casing, another casing, then intermediate casing, then finally again intermediate casing, then we have production casing or production string. Now this is a perforation. You can see perforation is basically we are doing creating some cracks into the formations so that oil can enter into the tubing strings and it can flow to the wellhead. Now you can see these are the different type of rigs that are used in offshore. The first you can see the fixed platform rig. On this platform is fixed and this is can be used up to the depth up to 600 meter, and further we have small scale tensile leg platform. This is a tensile leg platform. So into the tensile leg platform these legs can be extended towards the surface of the sea. This can be used up to 1067 meter or 3500 feet up to this much of depth. Then further we have the floating production storage offloading vessels. So this is a floating FPSO. This is a floating production storage of offloading. So during the production, this store the crude oil and it transport the crude oil. And this is submersible platform. This submersible platform can be floated to any place. It can be used up to the depth of 10,000 to 40,000 feet, from 3,050 to 12,200 meter deep. These are the different production activities, how the petroleum is produced. As you know, in the exploration, we find out and discover the presence of oil. Then we use drilling rig to extract the oil, and we produce the oil using the sucker rod pumps or other recovery methods. So as you see, after producing the oil from the well, it is being transported to the crude tank. Then it is preheated and salt is removed. Then other impurities are removed with different chemical processing. Then it is sent to the refinery unit, and from that you are getting different refinery products. This is another diagram for typical well structures and production. You can see the reservoir natural drive mechanism. Natural drive mechanism is when the oil or gas is flowing by it, its own pressure. No drive element is there. So this is coming out of this wellhead. It moves to the flow line. Manifold. Manifolds are uh, where the group of lines are joining. So these are the manifolds. So from manifolds it is going to a separator. Here into the separator we separate the soil, we separate water, we separate impurities, some solid element is present. Then further it is sent to the degasser. The oil, the gas that is dissolved into the oil is separated from degasser. Then further the oil is stored into the stock tanks and it is exported through the pump. This is another typical diagram of production of oil. You can see a well is drilled over here and wellhead is installed at the top, tubing head, casing head. So we are getting the product from casing head and tubing head both. This is gauge, pressure gauge. So now the oil is flowing, going to the these different lines. This is the injection gas manifold and injection gas to the gas export line. These are the compressor stations. These are the oil storage, and here you are exporting the oils. This is another well. Same action is being repeated, going to the production manifold and complete oil and gas moving to the storage. This compressor station is used to compress the oil when the pressure is reduced. This is another typical diagram of a wellhead, detailed diagram of a wellhead. You can see the wellhead have these kind of wing walls. At the top you have master valve. This is a pressure gauge. Here this is a cement surface casing. This is intermediate casing and this is a production casing, and this is annulus, the space between the tubing and wall of the formation, that is called the annulus. Then this is tubing. This is bottom hole choke. This controls the flow. The choke can be used to control the flow. Now this is a packer that will isolate the annulus. This is casing perforation. Perforation is basically making holes inside the casing so that oil or gas can pass through these holes. This is a reservoir. So this is one of the standard typical diagram of a wellhead. That's how the wellhead looks like. This is another picture of oil production. You can see at the bottom we have bottom hole pressure, oil produced at single phase. This complete zone is oil. Only oil is present. So through the tubing it is going through the wellhead. At top you can see the tubing head pressure. This is a choke to control the flow of the oil. This is a flow line pressure. Now this is going to the separator. Into the separator we are separating gas and oil. Now gas from the top part is moving at very high pressure. From the bottom you will see the oil that is stored in a stock tank. So this is tank, gas flow pressure, stock tank pressure. So this gauge is showing you the stock tank pressure. At the bottom you will see the oil. Now this is another picture that is showing you the production of fluid and gas both. At the bottom you will see this reservoir is perforated. We have made some holes or created some fractures so that the fluid can migrate into the wellbore, and this is a gas separator. So this fluid is moving, you can see, from the annulus and from the tubing. So here we have pump intake that is taking the fluid from the reservoir, and here we have a separator that is separating gas. So from the annulus or from the tubing there is a oil flow and gas flow. So from one line you will see we have the flow of oil, from another line we have the flow of gas. This is the power supply, electric power supply. Now we will see the another method of production. So now I will talk you about the recovery. We have natural recovery and artificial recovery. So into the natural recovery, when the reservoir flow by the pressure in itself, then that can be said as a natural recovery. No driving force is required to bring the oil at the surface. And secondary is artificial, means we need some artificial method to recover our oil from the subsurface. So in the artificial methods we have basically primary, secondary and tertiary recovery. In the primary recovery, up to 15% the reservoir's internal pressure pushes the oil out, and in the secondary recovery we have the recovery up to 20% to 40%, where water or natural gas push more of the oil out, and in the tertiary recovery we have the recovery up to 60%, where the chemical heat microbes or thin out of remaining oil. So we are using these chemicals to eject the oil from the reservoir. So into the primary method you will see the natural recovery is there, and or you are using some artificial lift method. This is a sucker rod pump. When the natural pressure is draw down and oil is not able to flow by its own pressure, then you are using the uh, sucker rod pump. And once there is no pressure within the reservoir, then you are using some natural drive, that is water or natural gas. You can see one injection well is here. You are injecting some water, and this water is pushing to the reservoir and is coming in through the production tubing to the well and being produced. And once you do some other operations, you want to recover more, you want to increase your recovery, then you have to use some thinning agent or some chemicals, polymers, to recover the oil. So you can see in this picture we have an injection well. This Through this injection well you are injecting some chemicals. This is a thinning agent, and this thinning agent is pushing the oil through the production well. So this is a production well and this is an injection well. Now this is a typical picture of a sucker rod pump. That's how the sucker rod pump looks like. You can see this is a prime mover. This prime mover keep on rotating, and it will rotate the crank of this, and the power will be transmitted using this belt, and the crank will further transfer the power to the beam. This will push it up and pull it down. This is called a walking beam, and this one is called a horse head. It will go down and then it will pull up. This is a bridle. This is a carrier bar, polished clamp. This is the polished rod. Now this is stuffing box which is connected to the wellhead, and now again this is going through the production tubing. This is produced fluid, tubing, sucker rod string, gas, then liquid level. This is tubing anchor. This is a plunger, pump barrel, traveling valve, standing valve. So you have one below the plunger, you have a traveling valve and standing valve. So once it is sucker rod is moving into up direction, so the bottom standing valve is closed and the complete fluid is evacuated. Meanwhile, traveling block valve opens and the fluid fills the plunger. Similarly, when it goes down, the traveling valve will be closed and standing valve will be open so that the complete fluid can be pushed out. These are the other artificial lifting equipments that can be used for different situations. You can see this is a sucker rod pump and this is a hydraulic pump. Hydraulic pump can be operated hydraulically, and this is electrical submersible pump. The sucker rod pump, low rate, heavy oil, some stand, low gas. Hydraulic pump can be used for low rates, temperature test, high cost. And the submersible electric pump are very high flow rates, no stand, low gas, power sources. And then we have gas lift for high flow rate, gas supply, offshore production. Then we have plunger lift, gas well, dewatering, final depletion, very low cost. Then finally we have progressive cavity pump. In the progressive cavity pump, some stand low gas, high viscosity. So these are the different artificial lifting methods or equipment that will be used in oil well to produce oil. Now this is a picture of the offshore production. You can see how we are producing in offshore. So offshore you will see wellhead is here. Then this wellhead is producing the oil and this is moving through a jumper. These are the different wells and they are coming into one manifold. This is a manifold. This one is manifold where many pipes are joining. So each manifold is connected to the riser base. This is a riser base. So riser base is lifting the subsurface fluid to the top, and from this, using the pipes, it is being moved to the floating production, storage and offloading vessels. And now it will move to the offloading body. This is buoy where the ship is moved. Now further, after loading the produced oil, this will offload to another vessel. From another vessel, the oil is transported. Thank you.